Hello everyone, welcome to my YouTube channel. Today we are going to discuss about derivative of exponential functions involving the chain rule. So in general, the exponential function looks like this. Fx is equal to e to the power x. So this is the most general exponential function. Now, as a base case, we know that if you get the derivative with respect to x, e to the power x function, the output would be e to the power x. So this is a special case in differentiation. Now here what we have to understand, in the function, the power is x and the variable associated with the derivative would be x. The output is x. So in other words, if you put something else here, say for example, you are going to put a dot here, then e to the power dot should be there. Then the output would be e dot. So this is the logic behind the derivative of the exponential functions. So now we will discuss few examples. First example, if you have ddx of 2ex, now we know that we can take this 2 out. So we can write 2 ddx of ex. So we know that ddx of ex is ex. So the answer would be 2ex. Now, if we have ddx e to the power 2x. Now here we have to think a little bit. The variable associated with the differential operator would be x here. And the power of the function would be 2x. So we have to find a way to get the derivative of this one. So we have to use a chain rule here. So what we do, we are going to construct the power. And then we use a chain rule here to seemingly cancel that term. So this is the chain rule involved. Now, as we all know, this one is nothing but e to the power 2x, because we have 2x here as a variable, times, you can take the power, you can take 2 out from here, and then 2 ddx of x. So this is going to be easy. So your answer would be 2 e2x. So that would be your answer. So now, third example, if you have ddx of ex squared, now you will use the chain rule here. So you are going to differentiate respect to x squared. Your function would be e to the power x squared. Then you are going to cancel x squared term, and originally you had dx. So this is your chain rule. So from here, you can get e to the power x squared times. Now this one is our base case number 1, which is power rule. We all know that. So let me remind you that ddx of x to the power n can be written as n x n minus 1. So accordingly, you will get 2x here. So your answer would be 2x e x squared. Now we will look into more advanced question. Question number 4. If you have a question like this, ddx e to the power x squared plus e to the power 2x. So if you have a question like that, you can use the summation rule here. First of all, we will do that. That would be ddx e to the power x squared plus ddx e to the power 2x. So now here, we will use a chain rule. So if you use a chain rule, d x squared ex squared. So you're going to cancel that dx squared here. And then originally we have dx. plus, so now I'm going to talk about this one. There we have to use the chain rule again, but this time it would be 2x e2x times d2x. So you are going to seemingly cancel that. So dx over here. Now, from this term, you can get e to the power x squared. And from this term, you can get 2x plus, this would be e to the power 2x. And from here, you will get 2. So finally, you get 2x ex squared plus 2 e2x. So that's the answer for that particular question. Now we will discuss another question, question number 5, which is ddx e to the power x squared plus x plus 1. So if you have a question like that, so you have to stick with the basics. Now what we will do, I will construct the variable associated with the operator, which is x squared plus x plus 1. Here you get e x squared plus x plus 1, and I'm going to cancel that. This is nothing but the chain rule, x squared plus x plus 1. Then you are going to divide by dx. So if you look at this term, that would be e to the power x squared plus x plus 1. Then when it comes to this, you can see summation here. So we will use the summation rule first. So that would be ddx x squared plus ddx x plus ddx1. So we all know this is going to be 0, and this is going to be 1, and this is going to be 2x. So after adding all of these, you get, here you get 2x plus 1. This is going to be 0. So from there you get 2x plus 1. And from this you get exponential x squared plus x plus 1. And that's the answer to that question. So finally, we will look into few other variations. If we have ddx of e to the power minus x, then what we have to do here, we have to use the chain rule again. So you will use minus x here as the variable of the derivative, and then e minus x. So you are going to seemingly cancel that, ddx of minus x. So this is my chain rule as we discussed before. Now here you get e to the power minus x. So that is the basic understanding of the derivative of exponential functions. And here you get minus 1. So the answer would be minus e minus x. And also, if you get another question like this, ddx of e to the power square root of x, then what I will do, I will construct square root of x here. And originally you have square root of x in the function, and I'm going to cancel that square root of x. So that is my chain rule. So you can see this is my chain rule. Now from here I get e to the power square root of x, and this one is a little tricky. You will use the power rule, which is ddx of x half. So if you use the power rule properly, what you will get here is half x half minus 1, and that would be 1 divided by 2 x minus half, and you can write that 2 square root of x. So 1 divided by 2 square root of x. So finally you can write the answer here, e square root of x divided by 2 square root of x. And that's the end of this discussion. And I will see you in another video. Thank you.